Am I audible? Can you hear me, please? So today we are going to discuss a few more problems on op-amp. So can you hear me? Okay, it's good. So today we are going to discuss few more problems. This is the first problem that we are going to discuss now. So in this problem, we can see that 3 op-amps are used. So this is one op-amp, this is another op-amp, and this is another op-amp. And it is said that the expression for V3 is of this form: 6V1 minus 4 upon 5 V2. Then question is, you need to choose this R1 and R2, therefore for values, so that you will get V3 equals to 6V1 minus 4 upon 5 V2. Okay, so this is the question. Now we will try to tackle these things. So it's not that much difficult. It's very easy. Try to identify each block. Okay. First, if I consider this side, so can I find the potential here? Okay. So this potential is nothing but potential across this thing. And as you know that there is no current flow in the op-amp, so no current can enter into the op-amp. So this circuit is independent. So whatever current is going through this 10K, same current will go through R2. So this 10K and R2, they will be in series combination. So we can find out this potential here. So this V plus, so if I call it V plus, so this potential is simply R2, it's a potential divider circuit by total 10 plus R2. So I am considering R2 in kilo ohm. Okay. So remember, R2 should be in kilo ohm. This times V2. This is the potential at this node, non-inverting terminal. Okay. Right. So what is the potential here? This is also same as this potential, because this is one unity gain feedback. So this block is nothing but unity gain feedback, because this is directly connected to inverting terminal. So this will provide a unity gain. So this voltage will not modify. So this potential V1, if I say, that is the same as V plus. Okay. So this is important. And then from this side, what is the potential at this point? So if I call it V2, so this potential will be simply a non-inverting amplifier. Okay, so V2 would be, what is the V2? One gain is 1 plus R1, RF, here RF is R1 upon total 10 plus R1. Is it okay? This is the gain multiplied by V1, small v1. Is it right? So this is your V2 here. Right? Now this one, correct? So what is happening in this point V3? So what is V3? V3 is simply, now we will be considering this circuit. Now consider that this 10K is of no use because no current is entering this side. This is 0 ampere. So this V2 will be considered as the potential at non-inverting terminal, and V1 is the potential at inverting terminal here. So what is V3? Is simply minus. So for this V1 it is inverting gain. So gain is, this is RF. RF is 10. So minus 10 upon this one, this R1 is 10 times this V1. V1 means V plus that we have considered. Is it okay? Plus this V2 is now non-inverting mode. So what is the gain? Again 1 plus RF by R1, 10 by 10 times this V2. Is it okay? So this, if you can simplify, it is minus V plus. V plus means simply, this one is R2 upon 10 plus R2 times this V2 okay, I think some big notation I need to use it. Okay, so this is your V2, this is your capital V2, don't be confused, the same name I have used here. Okay, this is your 2 times of this V2. V2 means 1 plus R1 upon 10 plus R1 times V1. Now you can just equate these two. So this 6 should be same as this one. So from here what we can get, so this 6 should be same as 2 times 1 plus R1 times 10 plus R1. It is 3. So I think in that case it would be R1 upon 10 plus R1 equals to 2. Is it okay? That will give you R1, I think it is 3 times, which one is 3? Sorry. So this is your 3. 3 minus 1 is 2. Am I making any mistake? Sorry, exactly, sorry, RF, because you are right, exactly right. So RF by R1, it is not a potential divider circuit. By mistake I have done this thing. Okay, so 1 plus R1 by 10, you are perfect. So this is R1 by 10 only. Okay, it is not there. So R1, so this R1 by 10 equals to 2. So R1 equals to, yeah, exactly, it is 20 kilo ohm. Because you are correct. Yes, it should be, because this one, this is simply RF by R1, means here it is R1, it is a 10. Exactly correct? So it will be getting 20 kilo ohms. Now if you compare this one, this minus 4 by 5, these things, that should be same as R2 upon 10 plus R2. Is it correct? So if you compare these two, so I am writing the same thing. It's okay, I don't have any space. So can I go for here? So this R2 upon 10 plus R2, this should be equals to 4 upon 5. Am I correct? So what is the value of R2? So this is 5 R2 equals to 40 plus 4 R2, and that will give you R2 equals to 40 kilo ohm. So because you are absolutely correct, sorry for that. So this is an intentional mistake. So this is R1 upon R, simply that resistance. So RF by R1, that kind of things are coming. Okay. Is it fine now? Okay, I think this problem is not that much difficult. You can also solve it. Okay. Now can I go to the next problem? This is the next problem. So can you solve it quickly? This is also very easy problem. Can you find V naught? What is V naught? So which method you will use in this operation circuit? Which method you will use so that you will get the result very quickly? Can you use superposition principle? Okay, because we are having three sources, two voltage source and one current source. This is one voltage source 3 volt, this is another 4 volt, this is your 2 milliampere current source. So for this one, we can find out the output potential V naught. So can you find this V naught? So quickly in one line we can solve it. So if you consider 3 volt at a time, first I will consider 3 volt source at a time. So this voltage source is not there, it is shorted. Okay, and this current source is open circuit. So if it is shorted, it is open circuit, there is no source, so this non-inverting terminal is zero potential. So it is simply a inverting amplifier. What is the inverting amplifier? This one. So this is, what is the gain? Is minus RF by R1. RF is your 24K. So this is 24 and 8 is this one, RF by R1, multiplied by the supply voltage is 3. So this is the first term when 3 volt source is acting alone. Okay, this is one term. Plus second term when this 4 volt source is acting alone. Okay, when 4 volt source is there, then current source is open, this is also shorted. So this potential and this potential same because no current is flowing. So it is a 4 volt only. So as if that 4 volt source is connected to non-inverting terminal. So what is the gain? So you should use non-inverting gain. So what is that? 1 plus Rf by R1. So 24 by 8. This is the gain multiplied by supply voltage. That is, it is in opposite form. So this is your minus 4. So that you have to be careful. So this is your minus 4 volt. Yes, good. And the last one, what is this? So 2 milliampere current is flowing. This is short circuit. So if it is not there, it is short circuit. Then what is the potential here? So that potential will be the supply potential at non-inverting terminal. Okay, so 2 into 4 means 8 volt. Am I correct? This will be 8 volt. So again, it is a non-inverting gain 1 plus Rf by R1 times this voltage I into R 2 into 4. Am I correct? Is it fine to all of you? Okay, good. So what is this? This is your minus 9 volt. This is your 4. So 4 plus 1 is, sorry, 3. It is the 4. 4 into minus 4 is minus 16. And this is again, this is 4 times, it is 32. So it is 16 minus 9 is 7 volt. Exactly correct? Good. So this is also very simple one. It's not that much difficult. So you have 3 voltage sources. You can easily find out the output potential using superposition principle. Now can you find this one? So in this problem, so this potential Vg, okay, can you find the output potential here? So this, here I want to find the potential V0. So how quickly you can find out the potential V0? So this is circuit. So for this circuit, you need to find out the output potential V0. This is a little bit tricky. It's not very easy. Okay. So be careful here. So at this point, what is the potential? So this potential is minus 5 volt. Be careful, because this is plus sign, this is plus, this is minus. With respect to ground, this A potential is minus 5 volt. So what is the V potential? VV. So VV is nothing but potential across this volt, this one. Okay. But so here one thing, you can't say that it is simply a potential divider circuit and its exact potential VB is 4 upon 1 plus or 40 upon 10 plus 40 times minus 5. This is not exact potential. Okay, because some current can go through this side as well. So what we will do, we will try to find out equivalent. This circuit I need to replace by Thevenin equivalent circuit. Yes, you can do. So here in this star to delta you can replace. You can go for star to delta conversion. So here also you can go for star to delta. That is fine. Then also you can proceed. It's a good idea. But I think it is very simpler. So this one, can you modify this circuit by one Thevenin voltage source and one Thevenin resistance. Okay. So what is the Thevenin voltage? Because this rest network, try to understand, the rest is this one. Okay, this circuit. So here this one 10K is connected at the output end, but it has no impact on the circuit. And this is your 6K, another is 4K, and here you are having one more, it is 5K. Then these two ends are connected. So here we need to find out V0. So this is also 4K. Because you are too fast, it's good, very good. So you have become very efficient in solving the problems. So this potential, what is the potential here? Thevenin potential. So Thevenin will be 4 upon or 40 upon rather 10 plus 4 is 50 times minus 5. Okay, and that will give you, so the minus 4 volt. Is it okay? So this potential is minus 4 volt, and what is the resistance? This resistance is 4 and 40 and 10. So 40 and 10, they are parallelly combined. What is that? 40 into 10 by 40 plus 10 is 50. Cancel out. So this is 8. So this is 8 ohm. So this is simply 8 ohm, 8K. Is it right? So this is, now what you can do, this 8K and 4K we can combine, and this will be your 12K. Right? Now here one important thing is that, so this is your 2 volt. Now how to tackle this one? So this potential first you can calculate. Suppose this is your D node, so I'll call it VD. First we will try to find out the VD. Okay, so can you calculate VD? So if this potential is 2 volt, this potential is also 2 volt. Okay, now we can easily calculate VD, because whatever current is coming here, that current is going through this side. In this way you can solve it, or you can solve it in other way also. Two sources minus 4 volt and 2 volt, they are connected. One is in inverting mode, other one is non-inverting mode. Then you can find out overall voltage Vd very quickly. That also you can do. So you can find an equation for that. So what is the equation? What is the current flow here? So this current flow, this potential is minus 4. So this minus 4 minus 2, the current flow this side, by 12K, that should be same as 2 minus Vd upon 6K. Am I correct? Is it correct equation to find Vd? Okay. So then this will be your 2. It's a minus. So if you simplify it, so minus 6 by 2 is minus 3 equals to 2 minus Vd. In that case, Vd equals to 2 plus 3 is 5 volt. Okay. So first we have got Vd. Vd is your 5 volt. Now thing is very simple. Again you need to take KCL at this node. If you take KCL at node, then you will be getting the output voltage V0. Okay. If you take KCL at this node, so what is the KCL? So Vd minus 2, the living current I am considering through 6K by 6, plus Vd minus 0 by 5K, plus Vd minus V0 by 4K, and that is equals to 0. Is it okay? Now Vd is also known. Vd is your 5 volt. If Vd is 5 volt, now you can find out the V0 easily. So if you replace Vd equals to 5 volt, then what you are getting? 5 minus 2 is 3. So this is becoming half. This is your 5 by 5. This is 1. And this is your Vd is your 5 minus V0 by 4. And that is equals to 0. Okay. So if you simplify it, what you will get? So I am writing here. Total LCM will be 4. This is your 2 plus 4 plus 5 minus V0, and that is equals to 0, and that implies V0 equals to 11 volt. Yes, it's good. So you can use star delta conversion. So if you can find out the star and delta star, then it is not a problematic. You can go for that. So this kind of problem is a little bit tedious. So be careful at every stage. So solve one part of this problem first and then move onwards. Okay. Good, very good. Now this is the next problem. The fourth problem. Can you solve it quickly? It is also a very simple problem. Okay. So here we need to find out the potential, this current I naught. What is the current through this 50 kilo ohm load? Okay. So you can see that this op-amp is unity gain amplifier. Okay, because this end is directly connected to inverting terminal. So whatever potential is there, 7 volt, that will be available here. So this potential will be your 7 volt. Okay. Very similarly, this op-amp is also having unity gain feedback. So unity gain amplifier it is becoming. Okay. So gain will become 1. So this potential will be again 6.98 volt. Now what is the rest block? That you need to identify. So this block, what is this one? So this is your difference amplifier or subtractor circuit. Can you identify these things? So this is your difference amplifier. Or subtractor circuit. So what is the output? So this output V naught will be simply, so you can see that ratio are same, 40:2, this is also 40:4:2, okay. Yes, it's a very small current because 50K is connected. So whatever voltage will be there, so this voltage will be, this current will be very small. So what is V naught first? So V naught will be simply difference between these two. So this is your RF by R1 times V2 minus V1. This kind of things we get, where this is your V2, 7 is, so in this case it is 40/20 times, this is 7 volt minus 6.98 volt. Okay. So this is 2 times of this one, and this is your 0.02. So it is 0.04 volt. Okay. So what is I naught? Now I naught is very simple to calculate. What is I naught? I naught is V naught by 50K, that is a milliampere. Okay. So this is 0.04 upon 5, 50, and that is your milliampere. So I can write 4 upon 5 into 10 to the power 3. So this 100 and this 10 to the power 3, and this is also 10 to the power minus 3, that much ampere. Okay. So this is 4 upon 5 is 0.8 exactly, and it is 10 to the power minus 6 ampere. Yeah, exactly correct. So in this problem what I am saying that, so first this circuit you need to identify. It will provide unity gain buffer. This is buffer circuit. This 7 volt and this will be again 7 volt. If this is 6.9 volt, this point is again 6.9 volt. Now this circuit is your subtractor circuit or difference amplifier circuit, because this ratio 40:20, this is also 40:20. Then the output expression for this output is simply the gain is RF by R1, this ratio 40 by 20 times this two difference V2 minus V1. Okay, so this is the expression for a subtractor. If it is a perfect subtractor. Otherwise, you can simply use inverting and non-inverting gain. You will be also getting the same result. Okay. So first we have got this V0, and once we will get the V0, simply we can find out the current. Good. So any more question? I think it is fine. Can you go for the next problem? So OP-AM is not very difficult. It's very easy topic. Once you will get good concept on this one, then you can easily solve the problems. So for this one, can you find out these two? What is V0 and what is your I0? Both. These two we want to find out very quickly. Okay. So can you solve it very quickly? So what is V0? So first, what is the potential here? So again identify this thing. So this block, your buffer circuit, simply a buffer circuit. So whatever potential is there, it's a 5 volt with respect to ground. So this is also 5 volt. Yes, because it is 25 volt. It's very simple, because this 5 volt is connected in non-inverting terminal, and this is now a circuit. A feedback circuit is there in negative terminal. So it's a negative feedback. Be careful here. Circuit is drawn in opposite way. So it's a negative feedback is there. So circuit is stable, perfectly stable. So this is your RF and this is your R1. So what is the gain? So V0 will be simply non-inverting gain is 1 plus 200 by 50 RF by R1. This is your gain. Okay, times supply voltage is 5 volt. That's all. So this is 54 is 200. So 4 plus 1 is 5. 5 into 5 is 25. Yeah, it's exactly 25 volt. Very quickly we can find out this output voltage. V0 is 25 volt. Now once you can calculate this V0, now what is I0? I0 is again simple. So you can see that there is no current flow here. It's a 0 ampere. So whatever current is coming from here, it has to go through this thing. So this current is I0. So simply I can say that if this potential is V0 and these two are connected in series, okay, so that current is same as I0. So V0 will be, so I0 will be V0 upon total this 50 plus 200 K, and that much milliampere you will be getting. Okay, so what is this? So it is 25 Here it is 250 milliampere. This is 1 by 10 means 0.1, exactly 0.1 milliampere. So these are two results. It's not that much difficult. 25 volt output voltage and 0.1 milliampere. Yeah, absolutely, this is very easy problem. Very easy problem. Sometimes people could be confused about this feedback. They can think that it is a positive feedback. It is not a positive feedback kind of thing. Okay. Good. So in this problem, can you find the voltage V0 if the resistance RF equals to 10K? If I put 10K, 10 kilo ohm, can you find output potential V0? Okay, so be careful here little bit. So this op-amp is having one feedback from here. Okay, from this output through 50K, it is connected to inverter terminal. Again, from this output of this second op-amp is also fed back to the input of the first op-amp. So this is also behaving as a feedback element. Yes, it is 15 millivolt. It is given 15 millivolt. Written that it is 15 millivolt. So you may get in the millivolt range only. So how to proceed? This problem is a little bit tricky. So this potential is 0 potential. So this is also 0. 0 volt. Okay. Now this potential we don't know. We need to assign one potential. Suppose it is V1 I am writing. And another, this output potential is V0, right? Now we need to get the expression for V1 and V0, right? Now if we consider the second equations, so if I consider this network, this circuit, okay, so anything could be connected as a load or you can take feedback, doesn't matter. So this is behaving as simply non-inverting amplifier. Are you convinced? This V0 depends on simply V1. It does not depend on any load. That we have discussed. So this V0 and V1 we can calculate easily. Relation between V0 and V1. So it is behaving as simply non-inverting amplifier. So gain, so what is the V0 will be, the gain is 1 plus RF by R1. So what is the relation? V0 is how much times of V1? It is 6, RF by R1 is 2, 6 by 2. Yes, because you are absolutely correct. The answer is probably 25 point something. Okay, so this is your gain is 1 plus 3 is 4, and so this potential is V1, so it is 4V1, correct? So V0 we have got in terms of V1. Now just we can take KCL at this node. Can I apply KCL at this node? So I write VI here. So the input voltage is VI. Later on we can put these things, okay? So if input voltage is VI, so what is this? VI minus 0 by 5K. This is the current to this side. And this current will be same as this current plus this current. Is it fine? That will be your 0 minus V1 by 15 plus the current through RF will be 0 minus V0 upon RF. RF is your 10. Okay, I think this equation is perfect. Now you can little bit simplify it. So V0 I can replace by V1 right now. So first I will try to calculate V1. Then if once we can get V1, V0 will be easily we can be getting. Okay. So minus V1 by 15, and this is your minus V0 is replaced by 4V1. So it's a 4V1 by 10. Okay. So if I go for LCM, it is 30 probably, and this is your minus 2V1 and it is your 3 minus 12 is it right? Am I doing correctly? Okay, so what is the value? Minus 14 by 14 V1 by 30. I could be 7 V1 by 15. Okay, so what is the V1? V1 is simply this 15 minus 15 by 7 times VI by 5. Okay, this is your V1, and once you will get V1, so this is your basically it's 3, so minus 3 VI upon 7. So V1 is becoming 6.42. Yes, is there any minus sign? I think minus sign will be there, no? This is minus 3 VI by 7. So now what is your V0? V0 is 4V1, and that you can consider minus 12 VI by 7, and VI equals to 15. So minus 12 into 15 by 7, that is the millivolt. So that you can calculate how much you are getting. So that value will be I think it is 180 minus 180 by 7. So this V0 is becoming minus 180 by 7 volt millivolt, right? So this is your 20. I think you will be getting very similar thing way. 25.71 exactly. Good. And this is also as it is given millivolt. I think this answer will be also in the millivolt. It's a minus sign. So minus 25.71 millivolt. I think it's correct. So this is a little bit tricky. Very similar questions I am giving you. This is the problem. Can you find input resistance of this op-amp? For this op-amp circuit, can you find this Ri looking from the input source Vi? Okay, so this is a problem. So how to find this output potential? So first, to find out Ri, what is the method? Method is that we need to connect a source. So this source Vi will be connected. This is your Vi, and whatever current it is supplying, this I. So Ri is simply this Vi upon I will give you the input resistance. Okay, so we need to find out the ratio between Vi and the current supplied by the source I. Okay, now here one important thing is that though there is one more feedback, but it is connected to source only. Okay, so this potential is Vi. So if I consider this network, this simply one inverting type amplifier. So V0 will be related to Vi. Whatever resistance it is there, whatever resistance is, does not matter. So V0 will depend on this circuit only. Okay, so what is V0? Easily you can find out. It's inverting mode. So minus Rf by R1. So minus 2 by 1 is minus 2 times this input voltage Vi. So minus 2 Vi. Okay. Right. So this is output voltage is minus 2 Vi. Now this potential is 0 volt, and this potential you have got that it is minus 2 Vi. Now we can find out total current. So what is total current I? This current supplied by the source, that is I, will be one current is through this side and other current will be this side. So this side current is Vi minus 0 by 1K, that is a milliampere. Okay, plus what is the current through this side? This is Vi minus V0 by 1K again. Am I correct? So this is your Vi and that is your Vi, and this is minus plus 2 Vi. Total is 4 Vi. Okay. So Vi upon I is simply 1 upon 4, that is kilo ohm. Be careful because all are in kilo ohm range. So this 1/4 kilo ohm, yeah, it is exactly 250 ohm. Why it is 200 ohm? So it is 1 upon 4 kilo ohm means 250 kilo ohm. No? Yeah. So here you can see that the input resistance is reducing because of these parallel connections. If we add some parallel connection means what? You will provide more path to provide a current. That's how resistance is further reduced. So if this parallel path is not there, then input resistance is simply 1K. Can you see that? If this part is not there, then input resistance was only 1K. But because of this parallel path 1K again, so input resistance is reduced further. It is becoming 1/4 of that. It is now 250K. Okay. Is it fine? So you can see that op-amp problems are not very difficult. It's very easy. So we have not considered any other circuit, or we have considered only negative feedback. But in next lectures I'll be collecting few problems on positive feedback as well and non-ideal op-amp. These are all considered as ideal op-amp. The gain is infinite, input impedance is infinite. But if input impedance is not infinite, if gain is not infinite, if it is finite, then it is more critical. Those problems are a little bit tricky. Okay, so those kind of problem I'll be solving next day, because today already we have taken 1 hour. So we'll be solving more problems on practical op-amps and positive feedback, Smith triggered circuit. And we may also consider the op-amp with capacitors like inductor or inductors, right, to get differentiator or integrator circuit. So any question do you have? No? It's fine? Okay. Thank you very much. Yes? Because you can go on. What is your doubt? So for semester purpose, one thing that you need to write it properly so that everybody can understand. Don't think that I'll be evaluating your script or any professor will be evaluating your script. Some TAs can evaluate your script. Okay. So thus you need to write down or you need to show all the steps clearly so that everybody can understand. No, I think because one thing that differentiator it's not unstable. Integrator could be unstable circuit. Okay, if you don't connect extra resistance, then it would be unstable, means marginally stable. So integrator, because if you consider integrator, so if you understand this thing, that you will be getting one pole at origin. If you find one pole at origin, so it is obviously conditionally stable or marginally stable circuit. So if you apply the signals other than DC signal, so for other than DC signal, this circuit will show some stability, means it will show bounded output. So it will be unstable if you apply DC input. It will go on increasing or decreasing, it will go towards infinity. For unity step input, the differentiator will be unstable. So you are giving these things practically, yeah. If it is a step signal at that moment only, it will be a spike and then it will be zero again. So one spike will be there whenever you will apply one, so at zero time, and then again it will become zero. So one impulse will be there in the differentiator circuit. It's fine. But that you can't say it is unstable. Because rest of the time its value will be zero. So practically what is happening? So if you want to use integrator, then you need to use one practical integrator. One resistance should be connected to your capacitor parallelly, right? Then it will become practical. So it will be also stable for DC input. So that's how this practical circuit. So I am not discussing here. So you can see that. So this kind of circuit, this is resistance and this is capacitor. If this is Vi and it is V0, this is R and this is capacitor C. Yeah, so its capacitance is 1 by Cs. So simply V0 will be minus Rf by R1. So 1 by Cs times R. So V0 by Vi I am writing. So it is minus 1 upon RCS. So it is having one pole in S plane. This is a real axis. It's the imaginary axis. Thus the ideal integrator, this kind of integrator, this is one integrator circuit. It is having one pole, it is a conditionally stable or marginally stable. But if you connect one resistance here, one RF, one more feedback, then you will see that you can avoid these things. It will be absolutely stable and your pole geolocations, you will see that your pole will be on left hand side. But very close to the imaginary line, then it can behave as integrator. If this pole is very close to the imaginary axis but left hand side, it will work as integrator, but it will become more stable. Okay. So differentiator, obviously we can use. Generally we are not giving step kind of things. So practically signals are all smooth one. That's how different circuit we can use in practice, and even integrator, this practical integrator we can use it. Okay. Good. Anybody, any other question is there? Okay, thanks for attending the lecture. So you can, we'll discuss more problems on next video. Fine. Thank you.